Hola! Welcome back to my math channel. Today we're going to go over some triangle congruence and how to show that two triangles are congruent without having to show that each piece of the triangle is congruent. Okay, so this is 12.2. So the first thing we're going to talk about is the side-side-side postulate. Now, in the last section we went over we talked about if a triangle is congruent, then all of its corresponding parts are congruent, so all the corresponding sides are congruent, and all the corresponding angles are congruent. So this side-side-side postulate allows us to show that a triangle is congruent just using the sides. So it says this: if the three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So for example, if we have this example here, it says AB is congruent to DE because they both have the 1 mark, BC and EF are the same because they have 2, and then AC and DF are the same because they all have 3. So if all three sides are congruent to all three sides of another triangle, then we can say the triangles are congruent and we don't have to show that any of the angles are congruent. Okay. So it says a postulate is an accepted statement of fact. The side-side-side postulate is perhaps the most logical fact about triangles, because if all three sides are the same, then the triangles are considered the same. It agrees with the notion that triangles are rigid figures, remember rigid motions. Their shape does not change until pressure on their sides forces them to break. So until you change the angle, the sides won't change. This rigidity property is important to architects and engineers when they build things such as bicycle frames and steel bridges. Alright. So, if we look at this, it's given us some information here. It wants us to prove that the two triangles are congruent. So we already know two pairs of sides are congruent. PN and LM are congruent, and then NM and PL are congruent because they have the 2 marks. So we just need to show that the third side is congruent, which they actually share this third side LN here. So I can put 3 marks here, and I can say that LN is congruent to NL, or LN, it's the same thing. And now we can prove that they are congruent by side, side, side. Yeah, because all three sides are congruent. So we don't have to worry about any of the angles there. Alright, same idea on this one. So we have the two pairs of sides that are congruent, and then this third side they share. So I can put it there, and then again we have side, 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 SSS. So that is also congruent, those two triangles. Alright, okay, the next thing we're going to talk about, this is working, okay. The next thing we're going to talk about is, it's being slow, the side angle side postulate. Okay, so above it here it says you can also show relationships between a pair of corresponding sides and an included angle. So the word included here, it refers to the angle or the sides between two other things. So if you look at this side over here, BC, this side is included between the angles B and C. Okay, because BC is between those two angles. We can also say that angle A right here is included between the two sides, AB and AC, because the angle is between those two sides. Okay, so the side angle side postulate, we actually use we need to use the included angle. This is waiting for a screen, okay. So the side angle side postulate, SAS for short, says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Okay, so what that looks like is this. We have AB is congruent to DE, AC is congruent to DF, and the included angle, so the angle between these two, are also congruent. So A is congruent to D. So because those we have the two sides and then the included angle are congruent, we can say that the two triangles are also congruent. Okay, so that means they are the same size and same shape. Okay, so we can show that by side angle side, those two triangles are congruent. Okay. Next, maybe. Okay. So this one, it says, what other information do you need to prove the two triangles are congruent by side angle side? Okay, so if you look at what we have already, we already have the top and the bottom side are congruent, F and DG, so that's one side. Our other side, if you notice, they share the side DF. So I'm going to put 2 marks there just to show that DF is congruent to itself. And then we don't have any of the angles, so we actually need to put that angle somewhere. So the missing piece of information here is the angle. So it has to be an included angle, so it can't be G and E because those angles are not included in between the two sides. Okay, and the angle we need has to be between this side and this side. So it's got to be the angle that I just drew, actually. So it's got to be this angle right here, and then also this angle right here. So we need to know that angle EFD is congruent to angle GDF. Okay, if we have that information, then we can use side angle side to show those two triangles are congruent. Alright, this one, same. Well, this time we have given an angle, and again we have the included side here, so we need to figure out what other side we need to use side angle side. So if you look, here's our angle here. We already have this side, so we need this side right here, so that way it becomes an included angle. So we have to know that this side is congruent to this side down here. That way that angle is an included angle. So we would have to know that LE is congruent to BN. So the top and the bottom are congruent. That's what we'd have to know. Okay. And then we have side angle side. Okay, so if you remember using the compasses and straight edges for our constructions unit, you can kind of think of the compass as forming a triangle like this. So you know that the two sides on the compass, so the pointy edge and then the pencil edge, those sides don't change length. So those are the same. So we can say this and this is congruent to this and this. Okay, if you're comparing two compasses. And then depending on the angle, that changes how long or how big of an arc you're going to make. So if your angles are congruent, so if this angle here is congruent to this angle here, then you should have the same arc measure. The reasoning behind that, or that just helps explain the side angle side postulate, because you make the same length here for AB and B or CD. So your two arcs are the same length. Alright, so on the next problem 3, would you use side, side, side or side angle side to prove the triangles are congruent? If there's not enough information, write not enough information. Okay, so A, we have two sides and an angle, and you just need to make sure that that angle is in between, or it's included between the two sides. So it is on here, okay, it's between the 1 and the 2. This one's also between the 1 and the 2, so you can use side, angle, side. We have two angles and or two sides and an angle again. So this one is in between the two sides, so that's good. This one, however, is not in between the two sides, so it should be right here. So actually this one, they could be congruent, but we don't have enough information to show that. So not enough info, we'll say. Okay, C, obviously you have all three sides, so side, 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 we don't need any angles there. And then D is also side, side, side. But if you look at D, Remember, these are called vertical angles when they make an X. So actually we can say that this angle is congruent to that angle, and we could also use side angle side here. So you could say side 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 or side angle side. So actually on that one either works. Okay, you just have to have the knowledge of the vertical angles to show that those two angles are congruent. Alright, and then the last one, same type of question. Would you use side 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 or side angle side to show they're congruent? Obviously all three sides are congruent, so side 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 does work. Okay, does side angle side work though? So if you notice, we have the angle right here. This is in between the 2 and the 3 side. This angle right here is included between the 2 and the 1 side. So those angles are actually not corresponding angles. So in this case, side angle side doesn't work because the angles don't match up. If, say, that angle, whoops, let's say the angle was moved, we move it to here. If it had that, then we could say side angle side because it is also between the 2 and the 3. Okay, but because they're not in the same spot, between the same two sides, we can't say side angle side. So this one only side 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 works. Alright, and that is all I have for lesson 12.2. So make sure you take the quiz, and I'll see y'all on the next one. Ka-chow.